Welcome to video number 5, and in this video we're going to do another example of finding the important parts of an ellipse. So I'm given that the equation is the quantity x minus 5 squared over 9 plus y squared over 25 equals 1. And right away I know that this must be a vertical ellipse because the bigger number is under the y-axis. So just make a quick note to yourself that this is like the parent function of x squared over b squared plus y squared over a squared equals 1. Okay, and that's an important note because we want to know that a squared is 25 and b squared is 9. So the first thing that I typically do when I graph an ellipse is I find the center because everything else builds from that point. The center is HK, and in this case we can see that it's 5, 0, okay? So what I'm gonna do, and I think I'll probably go down here, is I'm going to draw a tall, skinny ellipse where the center is 5, 0, and then I'm gonna work my way out from there. So if I go over 5, and again, this is not to scale, 1, 2, 3, 4, 5, 5, 0, here is my center. Okay, now, the length of the major radius. The major radius is always going to be denoted by the letter A, and since a squared is 25, I know that the major radius, or A, is going to be 5 units long. So what am I going to do with that? Well, A is the distance from the center of the ellipse to a vertex. So I'm going to count 5 units from the center, but I'm going to go up because the major radius is on the y-axis. 1, 2, 3, 4, 5. Okay, so starting here, I'm going to go 1, 2, 3, 4, 5. And this point here would be the point over 5 up 5, 5, 5, and that is one of my vertices. Okay, so one of my vertices is at the point 5, 5. And this distance here is A. It's 5 units long. Now, just since we're on the major radius, let's go down another 5. So 1, 2, 3, 4, 5. I would know my other vertex is, this is the point 5, -5. So I know my 2 vertices. So they're 5, 5, and 5, -5, okay? Now, if the length of my major radius is 5, I know the length of my major axis must be 5 plus 5, or 10. Okay, let's move on to the length of the minor radius. The minor radius is given by the letter B. We know that b squared is 9, so b itself is 3, and this represents how far I'm going to travel in the horizontal direction. So from the point 5, 0, I'm going to go 1, 2, 3. This point here is the point 8, 0. This would be a co-vertex. Okay, so co-vertices, I know one of them is at 8, 0. Now, I also need to go 3 units in the other direction. So I'm going to go backwards, right? 5, 4, 3, 2. The point 2, 0 is another co-vertex. Okay, let's see. What else can we find? Well, it's asking for the length of the minor axis. Well, if the minor radius is 3, the length of the minor axis is 6, okay? And I can sort of connect the dots. This isn't going to look so pretty, but you can see that I have a tall, skinny, or vertical ellipse, okay? Another interesting note is that the length of the minor axis is also the distance between the 2 x values here. The length of the major axis is the distance between these 2 y values. Finally, I need to find the foci. These are points that are on the major axis given by the point C, and we recall that C is equal to plus or minus the square root of a squared minus b squared. A squared is 25, b squared is 9, so c is equal to plus or minus 4. Now, what I need to do with that is go from the origin, or sorry, from the center of the ellipse. So if I'm here at the point 5, 0, and I know the foci have to be on the major axis, I'm going to go 4 units from the x value of 5. Does that make sense? So I'm going to go 4 units up. So from this point, I'm going to go up 1, 2, 3, 4, and this point here would be 5, 4. This is one of my focus points. Okay, so that distance of 4 is occurring from the center. Then my other one, I'm going to go here, I'm going to go down 4, 1, 2, 3, 4. This is going to be the point 5, negative 4. Okay, so we've successfully found all of the given information that I could ask you in a problem. I'm going to do another example, maybe another couple examples. Maybe I'll do some of horizontal ellipses so you can kind of get the idea how those work. So I will see you in the next video.